Welcome back everybody. If you haven't been here before, welcome. Today's video is a bit more about why you may see elliptical cycles on the planets or the starry motions. You need to understand with the flat earth physics that it's quite easy to explain, but the deeper you go it gets more tricky. But look at globe theory, that's just total garbage. And the only people who can understand it are the silly buggers who get taught and are indoctrinated with their silly equations. So what you need to realize is this Earth is run on the fluctuating magnetic field, because our whole realm comes from a vortex. And in a vortex you have a diaphragm. What does the diaphragm do? It goes up and down. Well, in the earthly system we have the vortex and the ecliptic plane. The plane at the top of the vortex is the diaphragm. So you could draw a circle with a vortex with a circular top and realize it pulls down, gets drawn down to push the field out to the southern hemisphere. So you've got to understand the toroidal field. Like take a balloon and you push down on the balloon, it bulges out. Well, you imagine that the ecliptic plane does that and it goes down. So and the ecliptic plane has the sun on its horizon. But just imagine my head's the sun, the ecliptic plane, this equilibrium, say, let's say it's the equinox. Well, it fluctuates, it flexes up to the north, and all the planets are on this flexing plane as they go around circles, all concentric circles. They flex up like this and come in, but they're still doing their concentric circles all the way around the black. Say my head's the black hole then, the black hole is the center of the ecliptic plane, and then it goes down and continues on down and out. So it's a lot wider out there. But this is creating the ecliptic plane to it's down and out, and this flexing up. So it flexes up. So the plane is bulging up like this. That's when it goes up and in. Let's start again. You got the ecliptic plane. So imagine a nice flat plane, dead level, and then in the northern hemisphere, summer, going up to the June solstice, it's flexing like this. It goes up and in. So the plane itself is bulging up like this. So the circular motion, the ecliptic plane, the concentric cycles of the planets are all moving in and up. Okay? And then when it goes up, it comes back down, equilibrium, then goes on all the way out to the south. That's when you get the sun pop into the southern hemisphere and come out from the southern end, the Antarctic region. So you've got the sun down and out, which means the sun's full time out there because it's a full circle. It's all the way around there. It's completely lit, but it goes a bit deeper than that. It's a bit tricky if you haven't followed me. So the ecliptic plane is now flexed down and out. All the concentric circles all stretched down and out. This is globe telling you it's perihelion, isn't it? Is that when the sun's closest to the earth down there? And then further away from earth when it's up here, or is it the other way around? I can't remember. I lose track of their garbage. The sun never gains on man. Man only sees the sun on his arc of horizon. It's just an image. It's a projected image onto his arc of horizon. Nobody can see any more the totality of the earth. All he sees is out to his horizon. As he moves, his arc of horizon will move and he'll see that portion of the earth. They cannot determine what's out there on a full scale. They make it all up, you see. They see so much and then they create the rest of it and tell you live on a spinning ball and everything does ellipses and all that just because that's what they've made up. That suits them. But when you know the true physics of the flat earth, you know they're all doing concentric circles, but it's all coming back to your personal arc of horizon. So if they're projections onto your horizon, which they are, because the sun is back here at the centre of the Arctic doing a circle. Very small circle around the horizon of the black hole. You see, and as that moves around, the sun is connected to the Milky Way. In celestial navigation back in the day, they called it the spider web. Well, this is the Milky Way. Okay, and it swings around the Earth just like all these other magnetic fields, curved like this. And there's a sun, 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 there's a sun. It's all coming out of here, because that's the true sun is in here, unseen pure plasma. But we get it out here in our realm, in the light spectrum, as an image. So what does it say here? Here is the sun, seen on any latitude, at the exact same time, any latitude, all the exact same time, on that same arc of longitude. So no matter where you live in the northern, we only work on the northern hemisphere here because the southern hemisphere is mirrored in all directions. So we just concentrate on the northern hemisphere. Anywhere on any latitude, from the Arctic right out to Kent to Capricorn, Egypt or somewhere, 30 degrees or whatever. But then you've got the tropical gap, right? 47 degrees here. So there's your 66.4, 23.4 degrees, say. That's how it works. And that moves around the Earth just like this. That's your 24-hour clock. But we don't receive any of that. We all get it down on our personal arc of horizon. So the images originating from here, whether you want to understand it spinning around in here, projecting onto your horizon, whatever you want to imagine, but the fact is it's all being projected onto your arc of horizon. So if there's a light source going like this over here, how do you think it's going to work on here? It's going to do this sort of elliptic type cycle, this wave sloping cycle. And this is what we get in the stars, don't we? Well, we do. Pretty tricky to explain. There's man's arc of horizon, okay? See all these waves here. Now, you can imagine a planet on one of these doing its motion. It's just doing a circular motion. But like I just showed you, the ecliptic plane is flexing up like this 1 degree per day. All year long it's moving 1 degree per day, which will send the motion upward to the June solstice and back down again to the December solstice. This is the wave you're getting around their globe, you know, the ecliptic plane wave, because that's how it works. If something's moving this way as well as moving into the north at the same time, then you're going to get that snake wave, the ecliptic plane wave. Okay, let's understand that. It's quite easy, really. What else have we got here? The sun peaks at midday as it is projected onto a direct alignment parabolically back to the observer. So you've got to imagine the observer's inside here, the image is coming onto him, and it's going to be bouncing off the wall of the toroidal field. If you want to understand more of this, go research magnetic mirror, because the tropical gap acts as a magnetic mirror. And they talk about an image being bounced off, you know, either way here. So if the image is coming in here, are we seeing the image here, or is it being reflected off here back to here? It's just a crystalline structure, and people need to realise that, because the whole atmosphere is full of moisture, and you've got the refraction of light. That's a no-brainer. If you know anything about anything, We've done that. We've got to go here. The actual sun, unseen, is doing circles back at the centre, but projects its image out into the curving magnetic field lines as one arm, called the Milky Way, into our light spectrum, sweeping around the Earth, seen at any latitude. Consider only the northern hemisphere at this stage. Okay? So I'm going to read some information they've got here about ellipses. To visually perceive that planets, I asked the question, how do we physically perceive, view elliptic cycles in the night sky? I'm trying to get my finger on it so I can break it down and show you how it works on the flat Earth. But it's pretty tricky because I can't draw 3D really. What have we got here? The sun comes into your horizon to pass over your horizon. So it comes around into your horizon because it's coming around the Earth in the tropical gap, you could say, because that's where it's been created. The dielectric, capacitance, electromagnetic induction, radiation, whatever you want. You know, in science, I'll finish reading this. The sun comes into your horizon to pass over your horizon, to go out of your horizon. So it comes around, goes over, and then back, and it just keeps going around the Earth. As a projection from the Arctic or tropical zone onto your fishbowl. Variation calculations. You know, talk about variation calculations, ancestral navigation, or whatever they're doing. Because you can imagine this is like a 180 degree arc over the man, right? But as the season changes, the sun's going down in declination, isn't it? So if it's 180 degrees like that, it'll just go straight over like that. There's your 180 degrees. But if it's sloping like this, then the light is going to curl around. There's going to be more length coming in behind here, which you don't see. So this is why we have to add on those calculations. What do they call them? Variations in your calculations, because it's gone down down on the horizon. It's going to disappear. You've got to lose it. And it's all due to this curvature. Do you know what I mean? That's a nice 180 degrees, but it goes like that. The field's going to swing around here more. It's not doing a straight over 180. It's coming around, you're losing it down here on the horizon. And that's another thing. Losing something on the horizon quickly. Now, science describes it quite well, but it's just not on a globe, or reasonably well, about why the sun drops away rapidly if you're near the tropics. The truth is, you know, go and check out their explanation, but the truth is, the magnetic fields, they come out of the Arctics towards the tropical boundaries, like this, comes out of the Arctic, comes out of the centre Arctic, they both merge towards the low pressure, because these are high pressure zones. So the field basically is one magnetic field, there's the other one. What happens, they're not crossing here, the magnetic field comes to here and drops straight down here. The ancients talk about this, namely in the Iliad. And you know what I've just seen recently on science YouTube channels, sites? You see, up to the centre here, we call them electrons, right? The magnetic field flow, you can imagine as electrons. And what they do is they find a pairing, because at this stage, Earth, this is Earth, there's a phi ratio, 1.618. Difference, like it's a 2 to 3, like there'll be 2 here, there'll be 3 here. 3 times 1.68, say. This is the way I like to think of it. times 1.618. So there's the ratio difference between the hemispheres. They're always different. But there comes a particular time of the year where it finds a balance. And there's all these different scales, all these different steps in the ladder. Like a magnet, you can break it down or make it bigger. Well, this whole earthly physics design is all broken down in like a magnet. So there's your system there, right? Always remember that they're not equal, but at a particular time of the year they are. When the two fields overlay. I've done plenty of videos on that. So anyway, this oddball, this difference here, where they do find appearing right where the sun is, and that's the spark that sets the sun, illuminates the sun. Okay, without going too deep into the sun being back here. This is our realm, our physical realm and understanding. Common man does not understand God, creation, the unseen. So here's the simple one to stick with, okay, before we go back to there. But what you see here is not reality. The truth is hidden back here, which I try to explain. And then I just confuse everybody because it's got the two systems. Let's just stick to this system here, okay? The electrons flowing in the magnetic field, like I've shown you here, right where the spot of the sun is, so the sun all of a sudden bang is there. Well, the field shoots into there and shoots into there. Otherwise it's just skimming off, avoiding this dielectric zone of the tropics. Right there it finds balance. The electrons find balance, but the oddball friction here creates the sun. But the balance remaining, that finds balance within it, gets drawn into the Milky Way to feed the real black hole, the actual black hole and the actual plasma sun. But the balance is actually feeding the black hole, because the black hole represents the state of rest, perfection, balance, and it comes from the leftover between these two here once they find equilibrium. Okay, that's what feeds back into there. So that's happening all the time as the sun's moving around the earth. Oh right, what I was saying is recently on a science video is so the rest of the electrons have been described as dying. They just fall away, they die, but nothing actually dies in our realm, does it? So there's a buzzy one. It just gets recycled. We don't actually die really in energy or our souls, but just our flesh dies in this physical world. We all get taken back through the Milky Way to be reincarnated to come back out again. It's all about water in our realm. Anyway, you come back, you're reincarnated in a different form. So the electron's supposed to die, but they get recycled too, because what happens is they fall away, become the weak field now, you could say. You could call it radioactive decay. But what they do is they come down to the earth, and that's the weak field down here. And this is where the dying, weaker electron finds pairing to find his way across the tropical boundary to get to the opposite field. You know, all the nursery rhymes is Billy Goat Gruff getting across the bridge. Well, he's not, but he is, isn't he? Things like that. Or there's one mythological story where this is the Norse mythology about the geese, I think it is. Oh yeah, those little birds. They breed at the top of the mountains here, and the young chicks have to jump down the mountain to meet with their parents. Pairing. Okay? So the chicks fall down the mountain where they meet their parents to take them across the water, the ferryman ride to the opposite Arctic to rise again, where they will live and become adults or whatever. This is how the system works. They drop down, they find a pairing down on the earthly level, and this earthly, it's all about the magnetic field, right? So in the Bible you've got the snake, along the ground thou shalt go for the rest of your days, and that's what it does, because the whole magnetic field represents the snake. He's come up, found this pairing. So this is like Adam, this is Eve and Adam. Adam's a strong force, he's on the northern hemisphere. In the centre of a magnet, you've got the strong force, and the weak force is out around here. They don't teach in science, but that's magnetism. So I've got Adam and Eve, and they get it on, and God said, what have you done? So he's cursing the magnetic field, because it's the magnetic field that's created the system here. So okay, now you've done that, what happens? You're going down to crawl in your belly, along the ground thou shalt go, and it says over the beasts, which is up and over here, over the cattle and over the beasts, all thy days long. So this is the continuous cycle the snake is going on all the time. Everything is all described in all the physical, mythological stories, all of religion, all the ancient, religion, all that, it's all there. So let's get back to what I was saying here. To visually perceive that planets follow elliptic orbits, not circular ones, you need to make consistent observations over a long period, tracking a planet's apparent speed and brightness against the fixed background stars. The key visual evidence points to a varying distance from the sun, which would not happen in a perfect circle. So this is how ignorant they are. I've been showing this for years, yet they ignore it. The black hole, okay, there's the sun, but the sun moves around the black hole. So if you've got a planet out here, and the planet's here at this stage, and the sun's over there, wow, do you think that distance is different to when the sun comes around and appears here? Do you think there's any difference there? This is how thick your flippin' science is. What do they call this? The minor axis, isn't it? And over here would be the major axis. This is how stupid they are. And then they go on to talk about the brightness of the star. Well, it's only brighter because it's out of the face of the sun, direct sunlight, isn't it? So that would be a similar scenario. If you got the black hole here, you've got the sun here. Now remember, the sun's attached to the Milky Way, so there's your daytime. So that you could say that's all daytime there. I haven't thought too much about this, but anyway, directly opposite would be the star, would be the most illuminated position for the planet or the star, wouldn't it? It's going to get a bit dimmer here and there, isn't it? At dusk and dawn, wouldn't it? Because the sun's coming close to it. And this is what the same thing happens with the moon. The moon spirals out over the planets and comes back in again to the centre. So at new moon, the sun has spiraled back into the face of the sun. The sun and sun and moon become one. One at new moon. New moon. That is showing us the X and Y chromosome the sun is. Then the moon leaves it, which leaves the Y separated from the X. And this is what we have in the physical world. That's why it says look up to see all the signs. And it's showing you the in and out cycle of life and death, life and death. Pairing, separation, singularity, duality. Because our realm is now a dual realm. Look, there's two hemispheres to your brain, and you have a male and a female. Back at creation, it becomes one again. New moon becomes one. Showing us the cycles of life. Visual observations for elliptical orbits varying brightness, apparent size. A planet appears brighter and slightly larger when it is closer to Earth and the Sun in its orbit, and dimmer and smaller when it is farther away. This change in brightness throughout the year is a visual indication that its distance from Earth and Sun is not constant, which it would be in a circular orbit with the Sun in centre. See how silly they are? They're not calculating on the Sun moving. And a recent video popped up exposing my planetary motions of the planets that Ptolemy had. I think they misinterpreted it. So they showed you the motion if the planet was relative to the moving Sun. And they're showing you the Sun going around quicker than the planet, and the planet on its side, but they are still drawing the planet going in and out, which is not, it's not. But they've drawn the other system correctly. They're showing you that the Sun moving around the Earth, that the Earth at the centre. So they're showing the Sun there and the planet following it and going in and out, but it's still following it. It's the main system. Now I put up years ago, but I just what do you call it? Brought it back to life a couple of weeks ago, and then I saw that on YouTube. So brighter, slightly larger when it's closer to Earth and the Sun. So when it's closer to Earth and the Sun, so this is where you got to realise that. Earth is from the black hole. Earth is from the hole initially in here. That black hole in here, back at creation inside the vortex, which is the centre of the ecliptic plane in here, Earth has come out of there. Earth is expressed out of there. So Earth is from the hole. And what science is doing is taking you back half the time and telling you that hole at the centre of the ecliptic plane is Earth. Okay, so they're saying that's Earth, but they're telling you the Sun is fixed, which means the hole is moving around the Earth, which is so stupid. When in reality we see the Sun move, the Sun is moving around the hole, moving around the Earth. Okay, so what did this say? When a planet appears brighter and slightly larger when it is closer to Earth and the Sun. Closer to Earth and the Sun. So that's Earth and closer to the Sun. Closer to the Sun. It's a bit confusing because it's a lot of things work in the opposite. Close to the Earth and the Sun. So you're going to say that's the Earth and there's the Sun, but they're fixing it. So Earth is going around the Sun. And they're saying when the planet is closer, it appears brighter and slightly larger when it is closer to the Earth and the Sun. Brighter and larger when it's closer to the Earth and the Sun. So it's hard, but they see it differently. So if the planet's here, they're calling that closer to the sun, but it's behind the sun because the sun will be shining this way. It's the Milky Way is like that or something. There's your Milky Way of the sun. They're explaining it back to front. It's hard for me to explain to you unless I get down to the specifics and have to have all that on my mind, which I have not. Varying speed against background stars. By observing a planet's position relative to the fixed stars night after night, you can track its movement. Well, it's called a wandering star because it's not with the stars. All the stars are in the central vortex. Okay? They're doing the S-curve over the night and back up again for the 24-hour day. 12 hours does the S-curve, 12 hours go back up. It's a 24-hour cycle, a 3D figure 8. But the planets are up top here doing concentric circles on the flat ecliptic plane. That flexes, or it goes the other way, flexes down and out, and then up and in. So when it comes up and in, it's your northern hemisphere, it bulges up, and then when it comes down, it's being drawn down, pushing the field out to the south. This is going down into Amente for Persephone to pop out to the southern hemisphere and eat some more pomegranate to have a sun rise in the southern hemisphere in their summer. And planets, they will be moving, like I say, the stars are in here doing their thing. The planets are moving against them, sort of like it's a different cycle. This is why they call them wandering stars. The stars are going at pretty much the same speed as the sun. There's only 3.54 minutes a day difference. But the planets are out from the sun, so they're on a slower track, aren't they? Okay? Even though the sun's just doing circles, the stars are doing this. That you've got to look at it two different ways, like electrons. You got is it a wave or is it a particle? So if the flat plane, you imagine, you see the particle on there, is it like a planet? But then down here, you've got all the waveforms in the vortex. And then you go, which way you're looking at it from to perceive it, you see. So you've got to understand what's going on. So the planets, as they go further out from the sun, they're doing longer and longer times. Like, it'll take like a year to catch up to a planet. Yeah, there's two different cycles, but this takes because the sun's quicker. So it's way quicker. So when the sun catches up to the planet, it's lapping it. Okay? But over with the stars doing their thing and the sun moving through it, it takes a whole year to catch up, to lap the whole star system and fall short by 20 minutes. So once again you go back to the two motions where the sun is contracting in for your tropical year, got the ecliptic plane contracting in, expressing out, coming in, that's the tropical year, and going back out. So imagine it's moving this way as well as going around this way every day. So because it's going that way and that way, this is how you get your sun analemma image, photograph. It's drifting this way, okay, gets around, it comes back this way, comes around from the other side. It's a no-brainer if you put your brain to it. Put your brain to anything after that becomes a no-brainer. A planet appears to move faster when it is closer to the sun. Obviously, same model. If the sun's coming around here and let's get rid of that and get rid of that. If the sun's coming around here, you know, the sun approaching that planet is going to look quicker, maybe, from our perspective, because the planet's a lot slower. But what do they say? A planet appears to move faster when it is closer to the sun and often Earth, and slower when it is farther away. Well, that's a no-brainer. It's just over distance, isn't it? So you're gonna see it approach the planet quicker, or once it passes it, then you start seeing them both go together. But as the sun's coming around this way, they want you to think it's fixed, so they're telling you, oh, well, the planet must be going that way. And this is their silly retrograde. So if the sun gets around here, and the planet's way over here, well, it's going to tend to seem a bit slower, isn't it? Because it's freaking a long way away in its cycle. They talk about such basic stuff just to confuse you, I think. The apparent speed changes throughout its cycle, which is visually inconsistent with the constant speed expected in a perfect circular orbit, or because they're once again not understanding the sun, moving the sun in the system. Retrograde motion loop, what I just went over. Over many months, planets occasionally appear to slow down, stop and move backwards. Oh, they're calling it slowing down here. But anyway, they're not moving backwards, are they? Everything's just going in the same direction. It's just the sun passing. It's not exactly passing out here, but it's cutting in on the inside track against the background stars before assuming their normal eastward path. Eastward. They say eastward because the sun is racing ahead. So if the sun is fixed but it's racing ahead, everything's dropping. Observed by Tycho Brahe and analysed by Kepler. They're all full of crap. Making equations to suit their imagination, you see, because they don't know the facts. I think I've gone through enough, explained enough. So you understand that, you'll understand flat earth easily. It can all be described quite easily. No one wants to talk to me because they know I know, and they want to stick to their bullshit bloody globe theory. Okay? So you won't be seeing me on any of their flipping globe channels. Okay, thanks for watching. Don't forget to put likes up, share, and think about joining Patreon for more information. Thank you.